So a rule of thumb used by chemical engineers to estimate the cost of a chemical factory is that the cost is directly proportional to the 0.6 power of the amount of chemical the factory produces per unit of time. Suppose that a toothpaste factory which turns out 15 tons per day of toothpaste costs $43 million to build. So, first part, write the particular expression, the cost of a toothpaste factory in terms of the number of tons per day it produces. So, first things first, we need to assign variables. And so the first variable we're going to assign, we're going to say x equals the number of tons. Y is going to equal our cost. In this, we're also given the exponent. We're told 0.6 power, so our power is going to be equal to 0.6. The equation that we've been using all along is y equals k times x all raised to that power. In this problem, we're already given an xy pair, and we're given our power. Our xy pair that we're given here is 1543. And I'm going to shorten that $43 million to make our math a little bit easier. So now we're going to go ahead and plug in our x and y as well as our exponent into that equation. And when we plug this in, we have 43 equals k, which is our unknown, times x, which is 15, all raised to that 0.6 power. And this one's really easy because in order to find k, we just need to take 43 divided by 15 to the 0.6 power. So we're going to go over to our graphing calculator, and we're going to go ahead and calculate this. And so we're going to take 43 divided by 15, all raised to the 0.6 power. And I'm given as a solution of 8.469. So the answer to that problem for our k is k equals 8.469. And so then I can take that and write it into my final equation. So then y equals 8.469 times x all raised to the 0.6 power. And that's the equation I'm going to use for the toothpaste problem. So now the next part asks us to predict the cost of building a factory to produce 500 tons per day. And so we know that x is going to be our tons. So we're going to put in 500 into our equation. So y equals 8.469 times 500 all raised to the 0.6 power. We're going to go on back to our calculator, and we're going to take that and plug it in. 8.469 times 500 all raised to the 0.6 power. And we're going to come out with $352.5 million. So that solution becomes $352.5 million. The next part of the problem is asking us, well, what if it's 0.07 tons per day? So we're going to put that into the same equation. Y equals 8.469 times 0.07 all raised to the 0.6. When we go back over to our calculator, and in our calculator we're going to take 8.469 times 0.07 all raised to the 0.6 power. And we're going to come out with $1.72 million. So the cost of that factory would be $1.72 million. Pretty simple once you get that equation. So now it's going to ask us, if you double the manufacturing capacity of a toothpaste factory, will the cost be double? More than double or less than double? Justify your answer. So obviously this is not a linear relationship. So if it's not a linear relationship, it's not going to be able to double. So if we take 2 to the 0.6 power, which is the power we're given, if we in our calculator take 2 and raise it to 0.6, we come out with 1.5157. And that number is less than double. So 1.517, that's less than double because it's not a linear relationship. So now that we've done two together, I'm going to get you started on the next problem. The next problem is very challenging, and so I'm going to walk you through the first portion, and I'd like you to use the math we calculate together in order to solve the rest of the problem. So we're looking at bacon. So bacon cooked in a microwave. I don't know how many of you are doing that, but who knows? So the number of minutes it takes to cook bacon in a microwave often depends on how many slices you put in at once. A popular brand of oven specifies 1.75 minutes for 2 slices and 2.5 minutes for 4 slices. So we have two points. Let's write those down to answer this next question. And the first XY ordered pair we have 2 slices takes 1.75 minutes, and 4 slices takes 2.5. So they're asking us if the number of minutes varies directly, and if not, why not? Explain why the number of minutes does not vary directly with the number of slices. So we can see on this part, 2 to 4 is an x squared value, but on this side, 1.75 to 2.5 is x raised to some unknown power. So we double our slices, therefore the time should just double, but it doesn't actually double. So, again, we're doubling slices, but we're not doubling the time. It should double if this varies directly, however, it does not. But we're going to assume the number of minutes varies directly with some power of the number of slices, and it doesn't necessarily have to be an integer power. So use the given ordered pairs to derive the particular equation expressing the number of minutes in terms of number of slices. The system of equations you get after substituting the ordered pairs can be solved for the 2 unknown constants. You must be clever, though, to figure this out, and guess what? Logs are back. So let's write down the information we know. We know that y is going to equal our time, and we're going to let x equal our number of strips of bacon. We have 2 ordered pairs. We have 2 and 1.75 and 4 at 2.5 minutes. And the equation we've been using all along, y equals k times x, all raised to some power. We don't know our power in this situation. So let's go ahead and use that information we know and solve. So we know y is equal to our time, x is our strips, and there are 2 ordered pairs in that same equation we've been using. So let's plug in those x's into our equations. So this first one would be written as 1.75 equals k times 2 to some unknown power. And our next equation, 2.5 equals k times 4 to some unknown power. But the interesting thing is this 4, I'm going to write him as 2 squared because it's going to simplify our lives here in a minute. So, for those of you that are confused, 2 squared is 4, and I'm just simplifying this 4 found over on the left. So now that I have those 2 equations, the wording is telling us that we are assuming the minutes varies directly with the power. So if they vary directly, we can take those 2 equations. So if I take 1.75 all over 2.5 and set it equal to k times 2 raised to some unknown power all over k times 2 squared unknown power. So All I've done is take those two equations and set them equal to each other because we're assuming they vary directly. So, next step, let's simplify. 1.75 divided by 2.5 is 0.7, and in fractional form, that's written as 7/10. On the right side, I can go ahead and simplify, and my k's are going to cancel, and I have 2n all over 2 squared n. And that side of the equation is also going to simplify to 1 all over 2 to the n. And so, I now need to find out what 2 to the n, that power, is. And so we're going to use the reciprocal and flip this equation around. And so if I use the reciprocal and flip, this can be rewritten as 2 to the n equals 10 over 7. All I've done is flip. So I know what 2 to the n equals. And now, when I have an unknown power, we know that we can use our buddy the log. And our buddy the log, we take the log of both sides to figure this out. So if we take the log of 2 to the n equals the log of 10 over 7. Remember, we can go ahead and pull that exponent over in front. So that can be rewritten as n times the log of 2 to the n equals the log of 10 all over 7. And now I can divide both sides by log, the log of 2. And I have my n on this side, and that's equal to the log of 10 over 7 all over the log of 2. And so we can then go ahead to our calculator to find out that value. So if we go over to our calculator and we take the log of 10 divided by 7 divided by the log of 2, we should come out with 0.5146, and we do. So then this value is approximately equal to 0.5146. And now that we have that value, we can take that p and plug it into both of our equations. And so in order to find our answer of using those two to find out the number of minutes, we then take our equation of y equals k times x to that value, and we're going to plug in our ordered pair. And our first one is y.75 equals k times 2 all raised to the 0.5146 power. And then we can solve this to find k equals 1.75 divided by 2 to the 0.5146 power. And if I plug that into my calculator, I'm going to get approximately 1.225. And so the equation then, after all of that work, ends up being y equals 1.225 times x to the 0.5146 power. And that's the equation I'm going to use to solve all of my other parts. You might be asking, why did I choose that ordered pair? Because it was the first one written. You could have chosen to use the other one as well, and you should come out with that same value for k. Now, in the next part, the question is, where would you set a timer to cook 8 slices? And so if you're going to set a timer, or 6 slices, sorry, to cook 6 slices, or to cook 8 and then 6 and then 1, those are going to be our time. And so that's what you're going to plug in for y, and then you're going to solve for x. Okay, so that equation, one more time, that we solved together that you're going to use to do the rest of this worksheet is y equals 1.225 times x to the 0.5146 power. And so you were going to use that equation to solve each part of C, and then you are going to need to find the domain in the range